In this video, I want to talk about the weighted average cost of capital. The mechanics of that formula is pretty simple, but I don't want you to memorize the formula. That makes it difficult. I want you to really understand what's happening, and when you understand what's happening, it makes it really easy to remember. So let's go back to the first picture, the overview of corporate finance. We have three decisions: the financing decision, the investment decision, and the dividend decision. The financing decision is like, I know I have to get money, so where do I get it? Well, I could sell stock, so I'm going to raise money, and those guys buying the stock are going to be part owners with me. They're going to be my partners. Or I could sell bonds. In other words, I'm borrowing money, so the people who loan me money, I'm going to call them bondholders. I'm going to take that money and I'm going to invest it. Whatever I do, if Caspian Sea Drinks, I'm making some kind of drink out of plums. Maybe I'm going to make a diet drink. Maybe I'm going to expand and do something different. But whatever it is, that's my investment decision, how I spend that money. And then there's also the dividend decision we won't have to focus on right now. But all these decisions depend on the size, timing, and risk of the cash flows. Now, where I get my money is going to determine the risk of the cash flows. So when I'm making this investment decision, I say, well, I'm going to be buying this equipment. It's going to produce these cash flows and these costs and all those things. So I have the cash flows and the timing of the cash flows. But what about the risk of the cash flows? Well, it comes from the weighted average cost of capital. In that formula, the weighted average cost of capital is equal to the weight of equity times the cost of equity plus the weight of debt times the cost of debt times 1 minus the tax rate. Now, let me go through with this kind of simple example and show you mechanically how easy this is. But then I want to add some of the intuition. So let's say that this WE, this is the weight of equity. So let's say this is 70%. If this is 70%, then the weight of debt has to be 30% because that's going to add to 1, right? So in other words, maybe I need to raise, I don't know, let's say I need to raise $10 million to put into this money machine. Well, where do I raise the money? Well, let's say that $7 million comes from equity and $3 million comes from debt. So that's 70-30. That decision is beyond the scope of this class. It will just be given to you. These guys raised some money. 70% was from equity, 30% was from debt. Now let's say the cost of debt was 13%. And I'll talk about where that comes from a little bit later on. Let's say the cost of debt was 7.4%, so 0.074. And the tax rate was 40%. We just assume that's right. So that's 1 minus 0.4. This is going to come out to be 10.10432. In other words, my weighted average cost of capital is 10.432%. So you could just stop there and say, well, I don't really care about why, which would be a mistake, and just know that just following through these mechanics every time is going to get you to the answer. But let's take it a little bit further and let's really look and see exactly what's going on and see where those different numbers come from. Alright, so my weighted average cost of capital is equal to the weight of equity times the cost of equity plus the weight of debt times the cost of debt times 1 minus the tax rate. So the weight of equity, just like I said, we're going to raise money, $10 million. And $7 million is going to be from equity, 30 million is going to be from debt. So weight of equity, weight of debt, you have those. Those will be given. That decision of how to do that capital structure decision, that financing decision, is a little beyond the scope of what we want to have here. But what about the cost of equity? Where does this KE come from? Well, it comes from two places. We can say the price of stock from the chapter we did on stocks is the dividend next year divided by K minus G. Remember that formula? Well, that is really KE, the cost of equity. We just didn't put the E there in the stock chapter. When I rearrange this, KE is equal to D1 over P0 plus G. So it's just doing the algebra. And what I want you to get from this, that's the dividend yield plus the growth rate. So to find this, you'd have to say, well, I know the stock price today is equal to, let's say, $25. Let's say the dividend next year is equal to $2, and the long-term growth rate is 5%. In doing this, we'll always use the constant growth formula for this particular setup. That means KE is equal to 2 over 25 plus 0.05, which is equal to 13%. The other way I could go about doing this is say, well, the cost of equity is equal to the risk-free rate plus beta times the market risk premium. This comes from the CAPM. In theory, these two numbers are going to be the same. In practice, they'll be different, but good news for us, we're dealing purely with the theory part here. So the risk-free rate, let's just say, is equal to 3%. Let's say that beta is equal to 1.25. And let's say the return on the market is equal to 11%. So then the cost of equity is equal to 0.03 plus 1.25 times 11% minus 3%, which is equal to 13%. The one word of caution, note that this is the return on the market. This whole thing is the market risk premium, so don't get those confused. The whole thing is the market risk premium. That's the return on the market. Okay, so at that point we have the weighted average cost of capital. We have the cost of equity portion. Alright, so just make sure we're really seeing this a million times. Weighted cost of capital is equal to the weight of equity, cost of equity, plus the weight of debt, cost of debt, 1 minus the tax rate. Alright, so when we look at bonds, where does that KD come from? Alright, how do I find that? Well, I know the price of a bond because this is what the bondholders put in, right? So the price of the bond is equal to the coupon rate over 1 plus, you did yield to maturity before. Well, it's not really, well, another word for yield to maturity is the cost of debt. We didn't do that as KD in the bond chapter, but it is KD. Like I said, we call that yield to maturity. So KD squared plus, we go on out to the end, coupon plus par over 1 plus K to the end. So this is the price of the bond from the bond chapter, which you probably got used to doing in the calculator, where you need to have what's the size and timing of the cash flows. So N equals something, payment equals something, future value equals something, and then what's the price of the cash flows, PV, put that in, I can solve for the interest rate. So I need to know those. And let's say it's a 10-year bond. So if it's a 10-year bond, let's say it pays semi-annually. So 10 years pays semi-annually. It's 20 payments. Say the coupon is 7%. So 7%, but pays semi-annually. So that's 35. And the face value is 1,000. And the price of the bond is $972.08. That's a 7. $972.08. Remember, you need to put that in there as a negative. When you do this in your calculator, the answer is 3.7%. But I need to annualize this because I stated this is a semi-annual pay bond. So the yield to maturity is equal to 7.4%, which is twice that. So we would then have the weighted average cost of capital, 70% equity. Cost of equity is 13% plus 30% bonds times the cost of debt is 7.4 times 1 minus the tax rate. And I'm saying the tax rate is 40%. That again would be given. And this then equals our 10.432%. So one last thing. Why are we doing the cost of debt times 1 minus the tax rate? Why do we do it there but we don't do it in this other spot? Okay, so let's take a look at why that is done that particular way. So we have, let's say we have EBIT. I'm going with a different example here, so different numbers than what I've used before. Let's say we have EBIT, which is earnings before interest and taxes. Let's say that comes out to be $1,000. And let's say we have a firm that doesn't have any interest. So when we subtract interest, we're going to have our taxable income. So first I'm going to do the example where we have no debt. So our interest rate is zero, our interest payment is 0. So our taxable income would then be 1,000. So then I want to take our taxes out, so subtract taxes, and we're going to have our net income. Let's say our tax rate is 40%. 40% of 1,000 is 400, and so our net income is $600. Okay, well, let's look at this. Another example, say we have earnings before interest and tax, so 1,000. Let's say this company decides they're going to sell bonds, and the yield to maturity is 10%. That means they're paying 10%, or $100. That gives my taxable income is 900. 40% of 900 is 360, and so the difference there is 540. So look at the difference in these numbers. It's $60. I paid 100 in interest, but my net income is only $60 different. So how could that be possible? It's because when I pay interest, I deduct that before I calculate my taxable income, and I pay my taxes as a percentage of my taxable income. So the $100 that I paid in interest reduced my taxable income by 100, which means I didn't pay as much in taxes. So this effectively cost me $100 in interest effectively cost me 60. So that's 100 times 1 minus 0.4. So the cost was effectively $60. Alright, so that's it for weighted average cost of capital.